Good webinar is still starting up for me. So thank you for joining. Good afternoon or good morning, depending on your time zone. Welcome to the webinar. People are still joining, so I'm going to give people just a couple minutes after the top of the hour. Sean, thank you. Welcome. And thank you again. We are going to give people just a couple more minutes to come in. We had a good registration for this, which is kind of pleasing. So I think number, so we'll just give us just a couple more minutes. And just as a reminder for people, for those of you who perhaps have colleagues who aren't able to come, or that you'd like to share this with afterwards, or you'd like to refresh, we are recording this, and it will be made available on WebPage's website within a few days. It takes a couple days for editing and posting it, but the session is being recorded and will be made available to you. For those of you who are not familiar with WebPage Solutions is a training company. We have been for I think about the last 20 years or so, serving enterprise clients. The slide says large scale, but it's large and small organizations who depend on WebPage for training needs across a very wide variety of different technology areas. We employ a lot of specialists in these areas and a lot of people who are like me, who are independent. I'm a contractor to WebPage, but from the context of presentations like this or course delivery, that's actually a good thing, because I, like a lot of people that WebPage has for training resources, are practitioners in the field. So this is not just something we're delivering. This is something we live with every day, and I'll talk about that a little bit when I get to introductions. There is a wide variety of webinars and free material that's available. You can follow the link for upcoming webinars, webpagesolutions.com/webinars. And we do post recordings of previous webinars. They're on YouTube under WebPage Solutions Inc. There's a huge variety of content available, and I invite you to take a look at that. And last thing before you start to get into content for this particular webinar, I am going to promote a course. Now this course is related to the webinar. It's about event-driven architecture. And it's event-driven architecture, theories, patterns, and best practices. What it really is a course on event-driven architecture focused on architects, designers, software engineers, practitioners in the field. It's intended to give somebody who has we don't assume any prior experience with event-driven architecture. It's intended to give people a fairly deep understanding of the role of the architecture, what it can do to benefit your organization, how it works, and some of the pitfalls to avoid. And I wrote the course, so hopefully you'll be intrigued after this presentation. A little bit about myself. I am, as I said before, I'm an independent consultant and I'm a trainer. I think of myself primarily as an enterprise and solution architect, but I've been in the field for many years. I have quite a bit of experience in corporate IT, spent a very long time in Loblaws, which, if you're not in the Canadian audience, is Canada's largest grocery retailer. responsible for applications development and operations, so basically end-to-end IT at various times. But I've also worked as CIO and CTO in smaller organizations, sometimes on an interim basis. And for the past 12 years or so, I've been an independent consultant. And the thing that I really find both interesting and rewarding is looking at the use of technology and how it can affect business, how it can positively impact business. And in the work that I do with WebAge in particular, a lot of what I focus on is trying to make technology concerns, which are often complex and difficult to understand, something that's understandable and actionable and approachable. And hopefully that will come across in this, this material. So without further ado, what we're going to be talking about today is event-driven architecture. And I'd like to give you a little bit of a sense of what it is, what's an event-driven architecture, but also why you might be interested in an event-driven architecture. And critically, why you might not be interested in it. So I want to balance some of the benefits with some of the potential costs and concerns. And we're going to spend a little bit of time looking at how an event-driven architecture actually works. We'll spend about 45 minutes on this, roughly. I'm going to say Q&A at the end. Though people who do have questions, if you want to drop them in chat or questions, as you go, at appropriate times, I'll take a look, and if I can answer them in line, I will certainly do so. So let's start with what event-driven architecture is. And the kind of core of event-driven architecture, of course, is an event. And to think about events, we want to think about things a little bit differently than we do in traditional IT software development. Starting with the realization that everything that happens in an organization is an event. You know, I sell something, I take receipt of goods, I send a marketing email to a new customer. And what event-driven thinking does is it focuses on what's happening in the business, but by focusing on how we actually handle each event. What do we do when something happens? And by the way, one of the things we might do when something happens is we might actually produce a new event. And what happens is in terms of behavior is that the complex behavior processes, the sequences of things that happen, they emerge from the patterns of events that happens and the actions that event handlers take. Event handlers are things that, well, take care of the events. This way of thinking is really complementary to how we normally think about a business. Normally, we think about business in terms of processes, and then we focus on kind of what do we have to do to accomplish something. That's the process. And instead, we're focusing on what's happening. So process first thinking, it focuses on sequence of actions, and events are they're mere side effects. Event first thinking really sees events as central because they really tell you something that something really interesting has happened that can be acted on. So they're kind of opening up that opportunity to do something. Well, that's event first thinking. What's an event-driven architecture? Well, an event-driven application is an architectural style. And it's an architectural style in which the event processors respond to events that happen. So things happen in the world and event processors deal with them. And an event processor might trigger new events to communicate state changes. Something happened, so we're going to communicate a new event. And an event-driven architecture, in an event-driven architecture, processing is asynchronous. You know, an event doesn't necessarily have to be responded to instantly, and is distributed amongst highly decoupled event processors. So the little diagram that's been building on the bottom of the slides is a really simple example of this. Let's take a little bit of a look at what's happening here. Let's say I'm an insurance organization and one of my customers submits a claim for health insurance. Well, that's an event, health claim submitted. And I have to respond to that event. And maybe the way I respond to that event is I need to validate. Well, that's an event processor. When I validate the claim, now that creates a new event that says, I've got it. Now I've got the health claim that's been validated. Well, that new thing that's just happened can cause other things to happen as well. I can process that health claim validated event with a payment, pay valid claim. But I can also do other things with it. I can reevaluate coverage needs, send marketing messages, whatever it happens to be. So you can see that complex behavior happens, but it emerges from the pattern of interactions between events and the event handlers. There are a few characteristics of this that are particularly important. One of them is that events, they correspond to things that happen in the real world. They correspond to uh, business concepts. And crucially, in event-driven architectures, those events, they're exposed. They're kind of something they're first-class actors in the system. They're not kind of state that's buried inside some internal component. Another thing that's an attribute of event-driven architectures is that message queues, or the things that the events kind of move through, they decouple the event from the processing of the event. In other words, something can happen and it can be processed later. Not only can it be processed later, but it might be processed by a number of different things, as you see on the right side of this diagram. And because there's that decoupling, it means that systems are very resilient to changes in load or even temporary failures. It's kind of an interesting property to have. And of course, the behavior is decoupled as well. And because behavior is decoupled in the sense that event handlers, where the behavior comes from, they're not directly wired to each other. Because behavior is decoupled, it makes it relatively easy to modify or extend. So expand on this idea and spend a little bit more time looking at some of the characteristics of event-driven architectures, where they come from and why they're important. So one of the characteristics of event-driven architectures is they are loosely coupled. And one way that they're loosely coupled is that event processors depend only on the events that they're listening for. So if I'm an event processor for paying a valid claim, the only thing I care about is validated claim events. The claim has been validated, so now it's okay to pay. That's the only thing that I depend on. And that's really important. It's not a kind of loose coupling in the technical sense, it's loose coupling in kind of the semantic sense, that the role that the event processors play is loosely coupled from each other. As we're going to see later, that gives us tremendous flexibility. The event representation, kind of the data, the way that we describe the event, is typically open and accessible. So we use a protocol form, a data format like Avro or protocol buffers or something. And this limits, it doesn't eliminate, but it limits schema coupling. That's another form of loose coupling. This is a little bit more technical in the sense that if we're using a reasonably self-describing data format, that means that an event, I can kind of, to a certain degree, just understand what it is just by looking at it. Now, obviously, that's a bit of an exaggeration, but that's a lot looser than something like a function call, which requires particular parameters, particular types. It's very well defined. So this loose coupling is a kind of key characteristic of event-driven architectures. Event-driven architectures are also extensible. And what that means is new behavior can usually be added by simply adding event processors. And when I add an event processor, typically that doesn't affect existing behavior. In other words, if a system, an event-driven system application is doing something and I add a new event processor, it does something else in addition to what it's already doing, but generally doesn't affect what's already going on. And that's a good thing. Think about what that means for extensibility and the ability to kind of respond to changes in business need. But that extensibility doesn't happen by magic. A well-designed system will produce events specifically to support future extensibility. What I mean by that is a well-designed system, the designers of that system will say, oh, I've done something in an event processor and I'm going to create an event basically saying this has happened. Maybe I don't have any use for that right now, but I anticipate that someone might make use of that event in the future. Essentially, you're building in hooks for future use. And when you do it right, this extensibility comes at kind of no cost. very low cost. So that's a very good thing. Now you might imagine that if a solution's loosely coupled like this, it's also scalable. Well, it is. Event-driven applications tend to be quite scalable because we can simply add throughput by adding event processor instances. Remember, those event processors, they're loosely coupled. They don't really depend on other things. So if I need more throughput, I simply throw in a few more instances, and now I can consume particular events, well, more per unit time. Typically, I can't consume them I don't process them any faster, but I can get through more of them per unit time. So my throughput is pretty easy to scale up. In fact, the characteristics of event processors, because they're kind of standalone things, because they're loosely coupled, they fit very well with elastic platforms like containers or Kubernetes or serverless in cloud. And that's really nice. It means there's a nice synergy between the capabilities we get from these platforms and the ability, well, to take advantage of platforms like that. And this scalability, it's not just scaling up, it's also scaling down. If I need less capacity, I simply remove some event processors. Great. One of the things that often happens when we're scalable is we're also resilient, and that's true here too, but in a kind of stronger sense. Because when something goes wrong, a failure, well, it'll affect processing that's going to happen kind of downstream of the failure. Let's say an event processor fails. It's no longer going to be consuming events, and it's no longer going to be creating new events. So whatever function that event processor was performing stops, but the rest of the system just keeps on running. So that's kind of nice because a failure that prevents events from being processed just causes events to queue up. They just wait. And eventually, when the cause of the failure is fixed, processing simply resumes. Now, this is true of kind of large scale failures, which could create a situation where a bunch of functionality just stops working and it'll resume later. But it's also true of very small scale failures, like an event processor fails because its container crashed and Kubernetes starts a new one and it just picks up where it left off. Well, that same resiliency is built right into the architecture. But not everything about event-driven architectures is great, of course. You have to pay for some of these attributes. And one way that we pay for that is that an event-driven architecture is potentially quite complex. That complexity comes from a number of places. One place is that the behavior of the system overall isn't something that gets written down. It's not like you can look at a piece of code and say, oh, that's the behavior of the system, like you can with something that's process-oriented. Because the behavior of the system is implicit, it's emergent. It emerges from the pattern of events and processors. And that means it can be hard to understand, particularly in large systems. And it can also evolve over time. Well, that's considered a good thing usually, but it can also contribute to complexity. Because as you add things to a system, its behavior evolves, well, that kind of makes it harder to understand as well. And the last source of complexity here is that loose coupling can be a bit of an illusion. And what I mean by that is, we think that components are loosely coupled. The event processor is loosely coupled to its interfaces, the events it consumes. That's all true. But consumers of events, they depend on the meaning of events. And the meaning of events isn't really explicitly represented. They have a representation, a JSON document or whatever it happens to be. But that's not the same thing as what it really means. So consumers of events can make assumptions, and small changes could potentially have unintended consequences. Think of a system where part of the system is doing sales analytics, and it's kind of got something that's an analytics event processor that's responding to sale events. And someone comes along and they extend the system to keep track of promotional material that's sent to customers, because that feels a lot like a sale. And it'll probably work, except sales analytics is going to see these other events that are sale-like, but they're not really sales, and it's going to draw a lot of wrong conclusions, and it may be hard to actually know that. So there's loose coupling, but there's kind of semantic coupling in the system that's really hard to represent. Complexity is an issue. The other source of complexity, of course, and I should have put this on the slide, is kind of obviously event-driven applications tend to have a lot of parts because all the parts are kind of independent things. And of course, the sheer number of parts, that can lead to potential issues too. So let's change gears a little bit and talk about why we might be interested in this. In what cases, what are scenarios where an event-driven architecture really shines, and where doesn't it? Well, the case for event-driven architectures comes from a number of conditions that are kind of common in business computing, and I think becoming more common. One place is where if your workload is highly variable, or you might have unpredictable increases in workload, this is a place where an event-driven architecture can really help because, as we said, they're really good at scaling. They're really good at being able to modify throughput. Another place where we might want an event-driven architecture is a situation where we need to be able to respond quickly to things that happen in business. And I don't mean I want to respond with low latency to a request. What I mean is something happens in business. A competitor changes their product, or we sense a market opportunity, or there's a regulatory change, whatever it happens to be, and I need to be able to deal with that quickly. In other words, I want to be able to have quick time to market. Often an event-driven architecture can really enable that. The little example I gave around being able to add event processors that have new functionality, that's where a lot of this comes from. Another place where event-driven architectures can be really helpful is where a business problem is really complex or it changes frequently. And that might seem a little bit counterintuitive because I just argued that a challenge in event-driven architectures is complexity. It's true. But when I have a complex business problem, it turns out that often being able to think of it in terms of events and how events are handled, it allows us to break the problem down. It allows us to be able to decompose it in actionable ways, often easier than trying to have a process view problem. And changes in the business space, the business problems, tend to be easier to deal with in an event-driven architecture than where we're largely process-oriented. And this is related to another case where event-driven architectures can be really helpful. The need to be able to deliver new functionality quickly. Again, it's time to market. If I need to be able to add some piece of new functionality relatively rapidly, event-driven architectures often give us the platform to be able to do that really effectively. And of course, the last one is when we have uncertain business growth. If we don't really know where our business is going to go in terms of growth, at what rate, I mean, obviously we don't want our business to stagnate, but we don't know whether we're going to become really huge or it'll grow slowly or it's going to be unpredictable. That scalability can also really help a lot in the scalability that event-driven architectures give us can really help. These are some very positive reasons. There are some cases not to use, scenarios not to use event-driven architectures though. One reason maybe to shy away is if you've got a very stable and predictable workload, you don't need the benefits of this kind of scalability. So why take on the complexity? Similarly, if your requirements are well understood, again, do you want to invest in something that's more complex to be able to deal with slowly changing requirements? See the question, I'll come to it in a second. And because another reason, and this is a big one, if your organization doesn't have the experience, doesn't have the capabilities to be able to deal with the complexity, don't try it. And sorry, what I mean by don't try is not, avoid event-driven architecture entirely. I mean, don't bet the next big system on it if you haven't done it. Build something small first. And always remember, just because something's trendy, and event-driven architectures are fairly trendy these days, that doesn't necessarily make it a really good choice. sometimes doing something that's kind of minimal is absolutely the right thing to do. There's a question, Dinesh, thank you. Is the decision to go with EDA made at an application scope, or advocating it at an enterprise scope seems unrealistic and almost inappropriate? So I'm going to have to read between the lines in your question. I think it would be very inappropriate to say everything we do as an organization should be an event-driven architecture. That doesn't make any sense to me. And in that context, yes, I think you make the decision at an application scope. But that's not the whole story. Part of the story will be, you may find, depending on what kind of tools you want to use, that starting an event-driven architecture for one application isn't a decision that an application team can make on their own. Not just about corporate standards, it could be about infrastructure. So you need some plumbing. We're going to talk about that shortly. It might be difficult to justify building out that plumbing just for one application. Now, cloud makes that easier. Again, we'll talk about that, but that's a consideration. On the flip side of that, once an organization has done a lot with event-driven applications, the decision to build the next application tends to lean toward, well, EDA, because you've already got a lot of stuff in place. And I don't talk about this a lot, and I probably should. It turns out that in an event-driven application, the boundary of the application is a little bit fuzzy. If I build something that consumes events that come from another application, that works really well, no problem. And so the more of these you've got, the more of a case there is for doing more of them. But the core of your question, do you make this on an application by application basis? Yes, you do. You do not go out and mandate that everything be EDA. That would be kind of silly. So thank you for the question. So let's do a really quick example of why extensibility comes from event-driven architecture. And I want to use this just as one example of kind of the power that this kind of thinking can give you. So let's say that we're an insurance company and we want to be, we've heard of this respiratory disease that seems to be circulating. Don't know much about it, but I want to be able to look in our customer base. Do we see evidence of this? What are our customers experiencing? In a classic application, which I'm calling process-oriented, it's not a real word, but I'm going to call it that. What we do is we'd say, I'm going to open up the code, I'm going to figure out where I'm going to put some logic in, maybe extend something that's already there, maybe it's some function, update claimant medical history or something. Package up the application, do a full build test release, and I've got that functionality for detecting these particular events. And it's buried inside the system. I've met the requirements, it works, but look what I had to do to get there. In an event-driven application, I do this a little bit differently. I would simply add a new event processor. Okay, it seems like kind of a simplistic way of dealing with it. What does that simple thing do? What it does is it listens for some relevant event. Maybe it's medical history updated. And it looks at those events and sees whether they have this condition that we're looking for. And if we do, we raise an alert. So I haven't actually modified anything. I've just added a little bit of behavior. And how do I alert? Well, what we do is we produce a new event. And that event is a scary respiratory event found. And what happens to that event? Well, that's the trigger that goes to another part. This is infectious disease surveillance application or CDC, I don't know what it is. We haven't defined that. But what you can see from this admittedly relatively simple example is it's, in a sense, really easy to modify or add behavior to an event-driven architecture compared to a traditional process-oriented application. I'm glossing over some details, of course, but it's good motivation for why this kind of architecture can really benefit an organization. Now, before we go further, I want to touch really briefly on a related topic, streaming applications, because streaming gets a lot of attention. It's a kind of popular paradigm, justifiably so. And I want to compare and contrast event-driven architecture and streaming, event streaming, just a little bit. In an event-driven architecture, we'll typically have what are called single-purpose events. That's an event that is carries some data representation for a particular purpose, like made a payment. These events are published to event processors, and the event processors consume them, and typically we don't keep the events after they're used. So kind of message oriented here. In event streaming, we typically do things a little bit differently. The events are kind of generic, and by generic, what I mean is the data that's represented, the representation of the event, isn't necessarily for just one thing. It's kind of more generic. So I wouldn't necessarily say, here's a payment event. I might say, well, here's an event, it's payment, it's associated with this order, and these are the order contents. I'm just kind of making that up. But I don't kind of, when I'm designing the event, I want to be able to kind of have a broad use. These events are streamed to a broker. Well, it's kind of the same thing as publishing it to an event processor, except that broker is providing the event to lots of potential consumers, and the processors watch for the event and they consume the ones that they care about. Technically, that's actually the same thing that happens in event-driven architecture, but events typically persist forever. I mean, not literally forever, kind of figuratively forever. And that gives us some interesting properties, like the ability to go back and replay history. Now, if this seems like these are kind of very similar things, they really are. I think it's kind of like a distinction without a difference. To me, an event-driven architecture and an event streaming architecture, they differ in emphasis. There's not a crisp definition between them. And in fact, depending on how I build it, I can actually have both, as we'll see in a moment. Now, why would I be interested in event streaming? Well, the places that really make me interested in event streaming are looking at events that are really core to business. They're things that are part of our core value proposition, the reason why we're in business. And therefore, they could be of interest to multiple business processes. And we can expect that they're going to be used in new ways as the business grows. So the generic events and keeping events around and having an event broker that makes them available to lots of different things, they all support these kind of cases of interest to multiple business processes, expected to be used in new ways. So event streaming is really, it's an event-driven architecture. I'm going to argue it's a kind of specialization of an event-driven architecture that's more oriented toward things that are happening in the business and the ability to make use of those things in the business. And in fact, it's quite possible to have your cake and eat it too. The event-driven architecture and event streaming patterns overlap. If we happen to use a persistent event store, way of keeping events around, and if we design events to be more general and self-describing rather than event-specific, then we can have both EDA and ES at the same time, same platform, use the same events. And I may have some applications that consume events that look very kind of classic event-driven architecture, other applications that are more, they look more event streaming. Because you really can have your cake and eat it too. They're really two faces of the same thing. Now, sometimes you say, well, in event streaming, what about complex event processing? It's a little bit of a jargony word for events processors that create other events that then cause other activities to happen. Well, application-generated events, they're an event stream too. And it gives us yet another thing that we can take advantage of and build event streaming applications around. Okay, so done a lot of what and why. Let's look a little bit at how. And this description of how is necessarily going to be fairly high level. We're going to try and avoid deep specifics, but it should give you a sense of kind of a little bit more how this works. And oh, sorry, I've got a couple questions that I want to address before we get there. My apologies, GoToWebinar wasn't giving me alerts. Can I isolate confidential events and the underlying data in an EDA? Yeah, so absolutely. So in an event-driven architecture, every event is, sorry, we tend to use the same term in multiple ways. An event type, or class of events, if you will, is distinct from any other event type. So in my health insurance example before, a claim to be validated was an event, and the validated claim was another event. Well, what I can do is I can say there are certain events that are confidential, and I just put security around them. And event broker platforms, things like Kafka, have good mechanisms for doing that. So yes, you can absolutely segregate confidential data from more public data. And in fact, the same kind of concerns that you have around application security exist in an event-driven architecture. You still secure all the parts of your architecture in the same sense that you would be securing the data inside an application. It's much more fine-grained than, say, securing a database. But it's the same effect. So yes, you can absolutely deal with confidentiality. Best of breed, can I provide a list of best of breed tools for modeling these events? I'm not going to be terribly helpful there. I work primarily at the architectural level rather than detailed design, and I use, honestly, simple diagramming software. I'm a Mac guy, so I use OmniGraffle, and that works for me. I'm sure there is more detailed tooling, but I can't really help you with that. There's a question about relating EDA to microservice architecture. Can I defer that, because we're actually going to talk about that a little bit at the end, because there's definitely a connection between them. So thank you for the questions. I'm going to try and keep on top of them now. Okay, let me turn back to a few things about how this actually works. And we're going to go through this at a high level, but I want to touch on kind of the key concepts here. And one of those key concepts has to be an event producer. So an event producer is the thing that creates events. It's the part of the solution that senses that something has happened. It's the trigger for things to happen. And it could be something like the arrival of a transaction from the outside world, or somebody clicks on a link in a portal, or it's kind of anything that will be the source of an event that goes into the event-driven application. The event represents a state change. Something happened. And it could be a representation of the state change, like here's a payment. So here I've got a fair bit of detail about what's actually happening in the state change. Alice Smith made a payment of $120 to this bank account. Now, if you look at this and say that's not very detailed, yeah, I know. This is cut down for illustration. The event also could be an identifier. So here's a payment ID. Now, the key difference is when we have a good representation of the state change, the event is kind of self-contained. In an ideal world, it's got enough information represented there that you can actually operate on it. When an event is an identifier, it means I have to then go and look that thing up. And that causes potentially all kinds of other concerns. And in truth, events can be a mixture of these things. We can have a bunch of kind of first-class information and pointers to other things. There's a whole craft to designing a good event, which we can't really go into here. But the kind of key thing is the event producer is the thing that originates events, and what it creates is a representation of the state change, a representation of the event, which it then passes into the system. Anything that happens in an organization could be considered an event. And interestingly, when an event producer creates an event, it doesn't know the consumer of the event, and it doesn't know the outcome. It doesn't know what's going to happen to the event. This is a source of some of that loose coupling. And I'm going to say that's a good thing, because it means that I can produce events kind of purely. I don't have to think about their implication. I mean, sort of. The meaning of that event results from what the event processors do with it. Now, I lied a little bit when I said I don't have to think about it much as an event producer. I actually have to think about it a lot. But the thing I have to worry about is am I representing the right information? Am I providing potential consumers of this event with the right things to be able to do something useful with it, whether explicitly or by providing references? And that's the art of the design of the event. What I don't have to be concerned about is how they're consumed or who's consuming them. That's another problem. So the other concern that I have to deal with as an event processor, and again, this is part of the craft, is do I put a lot of potential information in the event, which might be potentially redundant or consume a lot of resources, or do I make a really thin representation, just put as little as I can? Neither is the right answer. It's a trade-off. It's kind of the difference between a rich event and event-specific events, very specific events. But there's no particular answer. It depends on circumstances. Now, we do tend to use the event terms event and message interchangeably, and this is a little bit kind of wrong. In reality, an event is an abstract thing. It's something that happens in the real world. The message is the representation of that event. It's the kind of digital representation. Usually, we just say event because it's simpler, but technically there's a bit of a difference. There's a question, is the slide deck going to be distributed to attendees? The recording is, the deck itself is not, as far as I know. I'm not part of that process. Okay, so an essential part of the architecture is the event producer. Oh, sorry, I think I've got a couple of relevant questions. So there's a question from Dinesh, putting out identifying in the event defeats the purpose of loose coupling, does it not? Partly. So yes, it introduces coupling because you have to go to someplace else to resolve the event. That's absolutely true. What it doesn't do is, that's the only kind of coupling it adds. That definitely introduces coupling, but the event is still independent of how it's processed. So there's still loose coupling there, but you're right. It absolutely introduces some coupling. But remember, in architecture, there's no absolute answer. You can never have a system with no coupling. Everything's a trade-off. The reason you use identifiers is generally when the payload of the message would be too large to practically deal with. And that's the usual case for having identifiers. There's another question, isn't this also described as publish subscribe? It would have a catalog of events that can be subscribed to, and the trick is not to generate subscribed events that the event processes. The trick is to generate subscribed events the event process is watching for. Yeah, publish subscribe is an underlying mechanism. In fact, that's a good lead into here. Come back to that. So the event router. The router is the thing that provides events to consumers. It's also known as the broker, messaging layer. It's all the same thing. And good question, usually follows the publish subscribe messaging pattern in the sense that when you publish a message to a particular router, or if you want to use Kafka terms, a topic, then anybody who's subscribing to that message will see a copy of that message or see that message. So underlying, yes, it's absolutely PubSub. Yeah. We usually don't use that term in event-driven architecture simply because that's kind of the underlying messaging mechanism, but it absolutely is PubSub and has all the attendant advantages. Consumers indicate what things they want to subscribe to, what topics, and the router provides the events to all subscribers of that topic. And again, this is, we can call this an event broker or message queue. It's really all the same thing. So the router plays a vital part in the architecture. Often we don't talk about it because it's plumbing. It's the topics and subscriptions to topics. It's kind of underlying plumbing, but it's absolutely critical because it's the way that we get things to consumers, event consumers. An event consumer or an event handler, same thing, or event processor, same thing, receives events and it acts on them. And a consumer, it only receives the events that it's interested in because it subscribes to the topics that it wants to. And effectively, any other message, kind of anything else that didn't subscribe to, it'll never see. It's completely unaware of. Now, a consumer could also be a producer, and actually, usually they are. I consume a message, I do something with it, and then I publish a new event telling the world about what I've done about something. So, for example, I may have an issue payments event consumer, event processor. And what it does is it consumes a payment approved event, it issues the payment, that's a side effect, and it publishes a payment sent event. Now, why would I publish a payment sent event? Well, that's how other parts of the system would know that I did my work. See, if I just have issue payments, well, if I just have payment approved, how do I know that the payment was actually handled? It's actually gone out. That's what the payment sent event is for. So you can see the state of the system is represented by this rather rich collection of events. And rather than have state on particular objects, we represent state changes of objects as events. Sorry, catch up on a few questions here. Oh, yeah, we're good to point to catch up on a few questions. Would I talk about agent-based systems, how it's different from EDA? I'm watching time and I'm going to say no, just in the interest of time. We need to update a user interface to show the progress of multiple event processors, all contributing to a state change. Are there options for how best to do this? Does the UI become another event consumer? Listener, it depends. The user interface could become an event consumer. It could watch for the progress of events. That's one way to do it. Another way to do it is as side effects of event processors. It depends on what it is that you're doing in the user interface. Often, the kinds of things that we do in an event-driven application are longer running processes. And so when we have a user interface, it may be for only part of it, or it may be to get a status. So I don't see a lot of cases where people are doing kind of live update, like progress bars, off an event-driven application, but definitely getting status, absolutely. And there's a comment, I assume we don't interchangeably call EDA pub sub because pub sub patterns can be used in non-EDA contexts as well. Yeah, that's right. EDA and pub sub are two different things. An event-driven architecture makes use of pub sub, but pub sub is much more specific. So yes. Now, we can't really talk about event-driven architectures without mentioning Kafka. But I want to be clear, part of the reason I'm bringing this up is Kafka and EDA are two different things, not the same thing. Kafka is super popular, and it occurs as services like Confluent and managed Kafka streams. We can get this from websites. Very, very briefly, what Kafka is it's technically a distributed log, transaction log. What it physically is it's a cluster of machines that all cooperate, they all communicate. And when I drop a message on one, I say, here's a topic. I'm kind of oversimplifying, but I say, here's a topic. The topic is a queue of messages. The content of the message is from Kafka's point of view, just a binary blob. Kafka doesn't interpret the message. It just stores it in sequence. So a topic will consist of a sequence of messages starting at index 0 and increasing. And consumers of a message in Kafka will subscribe to a topic, and they'll be able to read the messages either from the beginning or from kind of as they arrive or from the middle, and they'll just consume the messages. What makes Kafka interesting is it's very, very high performance. It's highly distributed. So it's a really good platform for moving messages from multiple physical locations. And it keeps messages for a long time, kind of as long as you want, as long as you have storage space. So it's a really good message store. In a sense, it's very, very simple. There aren't a lot of semantics to it. It's really kind of straightforward. So what that means is it's nice as kind of underlying plumbing. But the role it plays in an event-driven architecture is as the router. It's in the diagrams you saw before. Kafka is the router. But I really want to make the point that Kafka and event-driven architecture are a couple different things. Now, getting a little short on time, so I want to move into challenges. And of course, one of the challenges of an event-driven architecture is that complexity. The behavior is emergent, It comes from the configuration of events and event processors. And of course, that can change over time. But because it's implicit, it's not explicit, it can be hard to understand. You have to look at a system and kind of think through what would happen what happens when this happens. And it can be hard to map a business process to an event-driven architecture. Actually, I shouldn't say that. What I find hard to do is go from an event-driven architecture to kind of back into what is the process it actually implements. Not because it doesn't implement it well, because it's hard to see because you're kind of looking from the inside out. Testing can also be complex because it's highly distributed in this emergent behavior. And the truth is, as systems really gain in complexity, it's just intrinsically difficult to predict how they're actually going to behave. Some of this is around issues like performance, but some of it's issues around what it actually does. It just can be very difficult to predict just from looking at the specification of a system. And I think that complexity is kind of irremovable part of making use of this kind of architecture. Another concern, challenge, is overhead. And you have to understand, loose coupling is way, way more expensive than in-process calls. If I've got a monolith and my functions are talking to each other kind of in the same address space, that takes microseconds. Taking an event, creating an event, putting it on a router, pulling it off, consuming it with an event processor, the overhead for doing that is tens of milliseconds, maybe hundreds of milliseconds, potentially even longer, depending on what you're doing. So you got to really be careful about this. So, fine-grained events, when I try to take events and make them kind of smaller, and the functions of an event processor kind of more fine-grained, means more of these components. We get lots and lots of these loosely coupled interactions. And this could get really expensive. And this expense, what that means is it takes a lot of CPU time, bandwidth, latency. Latency is the big one here. None of this is fatal. It just means you got to think about this. And it's just like any other distributed system. You got to think about trade-offs between how fine-grained you make the distributed components versus how much overhead you're imposing to make use of it. And you also have to be concerned about things like, if I've got some real-time system, this might not be the appropriate approach, too much overhead. If I've got human scale interaction, kind of fast interaction on a website, maybe this is not the right approach. Again, it depends on what it is. So you got to be really careful about thinking about that overhead. Another challenge is this notion of eventual consistency. Now, if you haven't heard the term before, what it refers to is the property that a distributed system comes to a consistent state. All parts of it kind of have the same representation of something, sometimes over time, sometimes an unpredictable amount of time. That's why it's called eventual consistency. And this happens because state changes ripple through the system. They're kind of events kind of percolate through the system. And the effects of those state changes, well, they take some time to complete because they're performed by different parts of the system in different places, different event processors. And that means eventually they complete, but for a while there could be inconsistencies while events propagate. I make a sale, but I haven't taken the payment yet. So what's the amount of sales that I've done? Well, it depends on which view of truth you're looking at. Now, again, this is true of all distributed systems. It's not an event-driven problem, but it's something you need to be potentially concerned about. And one of the things that's of particular concern is event-driven systems, like most distributed systems, don't usually have ACID properties. And that means that there usually isn't a concept of things like an atomic transaction. You need to kind of build mechanisms for dealing with that. And that's a challenge. And the last challenge that I want to raise is debugging, because it can be challenging to find and fix the root cause of a problem. It's not really always obvious how to kind of trace through what's happening, and there's no stack trace. So we really, if you're going to do an event-driven application, you've got to have distributed logging, something like Splunk or something like that. Again, this is not a challenge specific to event-driven architectures. It's common to distributed applications, but it's an issue. Now, there was a question about microservices and event-driven architecture, and we don't have the depth to go into this a lot. We don't have the time to go into this in a lot of depth. I'm just going to touch on this. Microservices and event-driven architectures are related. They overlap in some areas. A microservice as an architectural style is a way that can implement parts of an event-driven architecture, particularly an event processor. Because an event processor is a standalone, loosely coupled thing. Well, that sounds a lot like a microservice, doesn't it? What causes that microservice acting as an event processor to work? Well, it's called by the event router, or it subscribes to a topic. Now, think about a microservice. Traditionally, we think about microservices as something that expose an API and we call them. What if that API is actually a subscription to a topic? Well, now it's an event processor. And that microservice can generate new events. And from the point of view of the microservice, that's a side effect. From the point of view of an event-driven architecture, that's complex event processing. So they have overlapping concerns. What I don't want to do, though, is give the idea that you can just say, oh, I know how to do microservices, therefore I know how to do EDA. No. Microservices, you can use the microservice pattern to implement event processors. But just because you have microservices doesn't mean you have event-driven architecture. And I would argue the microservice pattern isn't always appropriate. One of the things about microservices, for example, is they have state. There are valid reasons for having event processors that maintain their own state, at least for part of the time. So, there's definitely a lot of overlap, but they're not necessarily the same thing. Okay, now I'm running low on time. But I've been doing questions as we go. Question, can event side effects be microservice calls? I would say it's the other way around. If we say we're using microservices as a pattern to implement an event-driven architecture, the thing that calls the microservice is the subscription to a topic. So a message, an event happens, and it causes the microservice to fire, because the microservice is consuming that topic, it's subscribed to that topic. From a microservices point of view, it may perform some activity, that's a side effect. It may also create a new event. And from the point of view of the microservice, that's also a side effect. But calling the microservice would, the event side effects is not the microservice call. It's kind of the other way around. I'm conscious of time, but I'm going to press on for just a couple other things. So one of the things that comes up is, if I've got a legacy application, can I turn it into an event-driven architecture? And the answer is, well, maybe, but this is actually a really big question. It's very similar to microservice refactoring. You can't just take an application and kind of magically turn it into microservices. Similarly, you can't take an application and magically turn it into event-driven architecture. And you got to be a little careful about the analogy between microservice refactoring, because event-driven architecture is significantly richer than a microservice architecture. But the basic idea is the same. Usually, I would think one would use the strangler pattern, which is kind of a fancy word for kind of gradually taking apart the application piece by piece. But in transforming to an event-driven architecture, typically what you do is you'd start with an understanding of the application data in the business domains. You'd make use of techniques like domain-driven design and event storming, that's a technique, to understand what events are, and then start to build, gradually chip away at the legacy application, turning it into an event-driven application. Now, I think this is really hard. I've never participated in one of these myself. But there's another way to do this. The alternative strategy is to keep the legacy application, but expose events. So leverage interfaces the legacy application provides, build adapters to expose and consume events, essentially to start wiring the application into the larger world, create new ways of creating events, triggering events from inside the application. And eventually what you're doing is, instead of trying to take apart the application, you're trying to expose it so more and more things are events in the outside world that you make use of. Use the same kind of analysis techniques and eventually replace the application. So ultimately, it's the same idea as the strangler pattern, but the technique is a little bit different. We're at time, so I'll forgive anybody who wants to go, but I'm going to keep for one more slide, and that's the relationship between event-driven architectures and cloud. And this is really about kind of synergies between platforms. Cloud services, they're kind of naturally loosely coupled. Typically, that's what we get anyway. And they have some things that are out of our control. A lot of response time issues in cloud is really out of our control. So it's a real advantage to have an architecture that's really tolerant of latency, which event-driven architectures are. But cloud also gives us another big advantage: the plumbing, the routers, the serverless as a mechanism for event processors. The things that we get kind of for free in cloud are things that really help us with event-driven architectures. So there's a nice connection between them, or a nice opportunity for connection between them. And I'm going to return to a few questions here. So are there typically multiple direct brokers? If a processor creates a new event, do they typically get pushed to the original broker? Oh, there's one broker platform, and the broker platform supports many topics. Each message type is a topic. So you'll have Kafka. You won't have several Kafkas, you'll have one. But it will have a topic for each event type. So the answer is really one, but that's okay. Is event storming a prelude to EDA, or can it be done even if not headed for EDA? I think you could do it for non-EDA as well, absolutely. I like the technique. I've used it in non-EDA situations because I find event storming is a way of understanding what's happening in a business. One of the things it can do is, my experience is, it can help draw out things that business stakeholders may not realize, that may not come out doing a kind of more traditional use case-based requirements approach. So yeah, it's more kind of general. So let's wrap this up with a quick summary. What an event-driven architecture is a collection of event processors, each of them responding to specific kinds of events or kind of event, and they cause side effects and they create new, more specific events. In that sense, an event-driven application is actually really simple. The basics of it are really simple. But the behavior emerges from the collective interaction of these event processors and events. And there's a lot of complexity that can come from that. Event-driven architectures have the advantage that they can be very resilient, highly scalable, and especially very, very extensible. But, and this may seem odd in the context of this talk, I would suggest using a simpler architecture if it's appropriate, if you can, and an event-driven architecture where you must or should. Do not jump to event-driven architectures to solve all problems. You can solve all problems with an event-driven architecture. Well, solve lots of problems with an event-driven architecture, but you'll probably spend a lot more than you need to when you use it when it's not necessary. Stay simple. But hopefully at the end of this, you'll have a good understanding of kind of where an event-driven architecture can actually help you and give you some significant advantages. Again, we have a course, which is an introduction to event-driven architecture. It's the one I referenced at the beginning, which is intended for architects, software engineers, and developers to give you a real strong foundation in event-driven architecture, much deeper than this talk. It's 2 or 3 days, depending on the version. And I'd invite you to look at that. Last question, where can we access the recording for this webinar? An email notice will be sent to you. to everybody who signed up for this event, you'll get an email notice when the recording is ready. I thank those of you who stayed a little bit longer. My apologies for going a little bit over time. We had some great questions, but I appreciate it. I hope this has been valuable. And thank you very much for your attention and time. There we go. I'm going to leave you on the marketing slide. And again, I'll stick around for a couple minutes for questions, but thank you very much for your time. Have a good rest of the day. Oh, it's a question around where can we see dates for the course. The next dates will be scheduled for January. It's not running until then. And I don't, as far as I know, the dates have not been set yet. So contact your WebAge rep at the inquiries here. Now we will be publishing when advertising the course when it's scheduled to run. Yeah, it's not been added to the calendar yet. Next run will be in I believe in January.